Hello there, my name's Vince from My Mate Vince, and in this video today we're looking at a SEGA Saturn. I did look at one of these quite recently on the channel, but I looked at a Mark II, which is this one here. You can see it's got round buttons, little indicator for whether it's on or off, and it's got a SEGA logo here. Also the design is different as well. Well, if you have a look here, it's kind of lined. We have these nice little dots here. We have a premium finish here. Buttons are different. Can't see any light to see whether it's on or off, but I bought it as no power, and sure enough, on the TV it has no power either. I tuned it into the same RF channel as that one, so I presume it's going to be the same. So let's get it over to the mat and see if we can get this Mark I up and running again. I'm looking forward to this. Right, so I paid roughly around £50. I think it was £49 plus a few pound postage, so maybe like £52. Right, we've got a load of screws around the place. Here, and oh, here and also here. So let's undo them and see what's happening inside. Ta-da! We are in. So this came out in the mid-1990s, and I believe it was the next model after the Sega Mega Drive or the Sega Genesis. Right. Oh, here we go. These light up here. Well, they should light up. So what? Where do they? Oh, we have got little LED. Oh, that's. Oh, we have. Look through. You won't be able to see. There you go. Can you see there? We have got a thing there. And also there, so it should be lighting up, and it's not, so that's good. So I suppose first things first, what we have to do is plug it in and see if we have any voltage coming out on these pins here. Now, obviously this is going to be a live power supply. I've got to keep my hand well away from the components on this side here. So if you have a look closely, you can see 3 different voltages coming out of this power supply. So this is going to be 9, 5, 3.3 and ground. So if I was to go between one of these two and these ones on my multimeter, I should get a reading. So it might be a problem with the board. It might not be a power supply issue. Maybe there's something on the board shorting something out. Let's plug it in and see what's going on. Right, so you can see how easy it would be to kill yourself because these are going to be live here. Obviously I'm not plugged in. Right, plugging it in now. And let's see what's happening down here. So volts DC, see if we've got anything coming out. Right, so nothing there on the 3.3, nothing on the 5, nothing on the 9. But it still doesn't necessarily mean that this is faulty, because maybe it's being knocked out. I kind of now need to unplug it, undo the screws, and then test it again. Apparently it can be bad for power supplies though, when there's no load, you know, to test them like that. Technical told me that, and when I asked him, you know, about phone, you know what, that seems so loose. That seems ridiculously loose. 1 second. When I asked him about, you know, well, what about phones? People leave their chargers in all day without being on the phone, but he said they have dummy loads and stuff like that. Right, I tell you what, we're unplugged now, but obviously there could still be high voltage in here. Let's just see if we've got anything on that fuse. Right, fuse is okay. That was the component that failed before on me, that one there. So I think we need to take this out and then see what's happening. So the Sega Saturn was hugely popular in Japan, but it was not so popular everywhere else. So I think in Japan it has like way more games than that was released for you know, UK, European, and in America. Right, I'm just being a little bit careful because I don't want to get shot. There we go, we are free. Okay. Where's that big cap? So let's just check the big cap here on the primary side. See what sort of voltage we have left in it. Fine, we've only got 1 volt in it. Yeah, so that's okay. And all of these are going to be on the secondary, aren't they? So they're going to be lower voltage. What are they, 10 volts? 10 volts, yeah. Right, well, I suppose we have to start going through the power supply and seeing what is going on. Let's do a visual check to begin with, and then we can go from there. I'm just going to undo this power button because can you see it needs to go through here first of all before it goes into the circuit. So we need the power button to be out. Which is easier said than done. Does this cap not come off? Oh God, that was quite hard. Right, so if this board isn't putting a fault on, then it means that both Sega Saturns that I've looked at have had faulty power supplies. So let's check this again with everything unplugged. Am I going to be able to tell which is on and off on this? That's weird. When it was in the thing, you could actually tell the height difference. Now it doesn't seem to. I hope I haven't broken it now by lifting the top off. Let's see if it latches on. I don't think it's latching on. That's annoying. Well, I've broken that, haven't I? Right, let's see if we can fix this because we need this working. So all I did was take the cover off. There's nothing on here that would make it latch on, is there? No, that's just screwed in there. Right. Unless there was a chance that the switch was faulty, and that's why it wasn't, that's why it wasn't turning on. But to me, it looked like it was lower down. It definitely looked like it was lower down when it was in the console. Right, this is going to be one of those things that's just going to spring out and go everywhere. So what do I have to do? I have to probably undo it from the bottom there, undo these two bits, take this metal thing off, and that might give me access to the inside. But I don't think that this is the fault. I think I caused this by pulling that lid off, because it was very hard to take off. Right, is it going to spring out? Hold on now. Please don't spring out too much. Excellent. Right, why aren't you latching into place? Do this thing here, in here. Can't even see how that works. Ah, look. There's a broken bit here. There's a broken bit now. Where did that go? That's obviously what the problem is, isn't it? Yeah, I suppose there's no groove for it to travel in. So normally when you press it up and down, there's going to be, if you put this in its place, there's going to be a nice little groove for it to travel in. So I don't know exactly where this goes. But if this is in there somewhere, then it's going to, when you push this down, it's going to guide this down one way, and then it's going to lock into place. And then when you push it down again, it's going to want to go the other way. So I'm certain that I caused the fault on this little switch by pulling off the lid too hard, and it would have pulled up that metal thing against the plastic and just snapped it off. So obviously there's still going to be a fault on the power supply. So to make it easier for the testing, I'm just going to bridge over with a little bit of wire the switch contacts so we can fault find the rest of the power supply. So it is annoying that I managed to break the power switch so easily, but such is life. So before we fault find the power supply, let's mention our sponsor of this video, and that is PCBWay. PCBWay have over a decade experience in the PCB industry. They have state-of-the-art manufacturing facilities, and they use the latest technology to produce high-quality PCBs that meet your specification. At PCBWay, they have a range of services including PCB prototyping, PCB assembly, flexible PCBs, high-density PCBs, CNC machining, and 3D printing. Now, if your project is going to be using components that produce a lot of heat, you could think about using aluminium PCBs because it will allow for better heat dissipation. It will transfer heat away from those components. And guess what? PCBWay do aluminium PCBs as well. So a massive thanks to PCBWay for sponsoring the My Mate Vince channel. So now let's get back to testing this internal power supply for the Sega Saturn Mark1. Okay, now let's plug it back in just in case, you never know. Maybe it was always faulty. Right, plugging it in here, again keeping my hands well clear. Right, I'm plugging it in, just make sure, hold on. Right, plugging it in now. And let's just check the output. No, so I broke the switch. How irritating is that, just by taking the lid off? Right, okay, unplugging it. And now turning it over without touching it. Plugging it back in. So, bridge rectifier. Is okay to there. Now, so let's keep on here. 1 second now. So if we stay on here and go here, we should have a reading, yes? Yes, we have. So we will have voltage in that capacitor. So it's working up until there. Where do you go to after that? Bear with me. Right, so we definitely have voltage up to the capacitor. Does anything look dodgy? So in my last one, this was blown. You could physically see it had blown right the way across, but maybe it is a weak spot on them. I think because it all looks good, I think we should just go with what we did before. Let's take off this and see if we can get a reading from it. So I'm just going to use my desolder station to take it out, and then we can put it in our component tester and see what it's reading. While I'm doing that, I'll give a shout out to the My Mate Vince Massive, and this month the members are kitdigital.com, Kip Hakes, Max Rokotansky, Having Fun Repairs, Will Michaelis, Chris Seal, Felipe at MrKeebs.com, DJVG, Pigsy, Robert from Timsy's Auto Air, Daniel Watson, Zeeks C, Anthony Dean, Bazza2, Operational 117, Russ Melanson, Save Our Stuff, Ellis Garbett, Hunter Short Repairs, and Gaspar Heller. Massive thank you, guys. Right now, let's pop this into the component tester and see what it's reading. Right, let's see if it brings anything up. 2 diodes. Okay. Spin it round. It's taking a long time. Oh, there we go. 2 diodes. I think that's probably okay. Oh, this is reminding me of the N64 power supply. Problem is, if I've got no visual indication of anything, I don't know how to fault find it. I mean, it could still be faulty, but it's definitely reading something. It's not. It's just saying 2 diodes. It might well be correct. See what I'm going to do? I'm going to unsolder the optocoupler and I'm going to unsolder this, and we can check both of them. One in here, and then we'll check the other one by putting voltage into it and seeing if the resistance changes. I chose these two purely because I thought they might be the most likely thing. So the optocoupler is responsible for sending feedback from the secondary side to the primary side, and that other thing looks like some sort of switching transistor, so maybe it's working quite hard again on the secondary side. So yeah, that's why I've picked them two, the only reasons. Right, let's see. So on this one here, you can see it's got like 2 diodes going into each other. So it's like some sort of double diode package thing, isn't it? Right, yeah, 2 diodes. Yeah, again, I think that looks okay. I don't think I'm going to be able to fix it. Let's just see if this is going to read a diode. So nothing that way. Diode, so that's the LED side here. So let's solder on a 300 ohm resistor this side and then put voltage into it and see if it changes on this side here. Then we know that this is okay. Right, this opto coupler here is PC123, so I'll type that into Google, and top left is anode. There is an actual dot next to that. Bottom left is cathode, and then we have collector here and emitter here. So I've got my bench power supply set to 1.5 volts or thereabouts. That goes there, that goes here. Now, if we put the leads here and here, we should be able to see a resistance, and if we change the voltage, we should see the resistance will change. Right, so we've got 6,000 ohms. There we go, it's settled at 5,800 ohms. So now let's up the voltage to 2 volts and see if it changes. Yeah, there you go. Optocoupler's working. That's 2,600 ohms. Let's go to 2.5 volts. Yeah, so you can see as I'm upping the voltage, the ohm reading is getting lower, isn't it? So what that does is I've turned on this LED now. There's an LED this side here, and what's it called? A phototransistor or something this side. So there's no electrical path between them. It's done for safety because can you see that this is going across the board? Is this the only component going across the board? Well, we've got another one down here, yeah. So we've got like the safety capacitor here, and we've got the opto coupler here, and there's no, but this is a special safety capacitor that doesn't, I think it doesn't go short, something like that. You can read up online about it, but it's, I don't think there's any chance of that bridging the primary to the secondary. And likewise with this, there's no physical path because it's shining a light, and this side's saying hi. Well, sorry, this side's shining the light, and this side's saying hi. Yeah, I can see you. So that's how it does the feedback, you see, without any danger. So I think that's working. I think that's working, and I think this is working. So this is getting, for me, increasingly difficult now. I think what I'm going to do is I'm going to take apart the working Sega Saturn, start swapping parts over, because again, I'm not knowledgeable enough on power supplies to be able to fault find it any further than what I've just done now, which is a bit of a shame. Okay, brilliant news. They are exactly the same. Same components here and here. Opto couplers labelled up the same. They're identical, which is fantastic. So that means that I should be able to find out what's wrong with it by measuring the differences between here and here. So I'm going to pop this one out. Also, other good news, you can actually take them off by, if you have a look closely here, can you see that there's a little kind of a slot here, and there's one over the other side as well. So what you have to do is, it's still fiddly, but if you get some tool like this and put it in one side and the similar tool the other side, then you can kind of turn it and it widens it up. There you go, that's one lot. Because obviously I have to change the buttons. If you can't get the version 1, I'll have to buy the version 2. But that's no bother, because I should be able to, there you go. Now, you see I took that off without putting a lot of strain on here, and this is still working. So good news is then, for around about £10, which is expensive, I will be able to get the switch. Lesson learned, and because I failed on my one now, you know not to do that on your one. So yeah, it's not a waste. Right, okay, I'm going to take out this power supply here, and then I think to begin with I am probably just going to swap out. Well, I suppose, should I swap them out, or I could measure them? I'll take it out. What I might do is I might try to get some measurements, but the problem is I've taken these out of circuit now, haven't I? But I might be able to tell with just a multimeter what's wrong with it, you know? I think I'm going to take a guess that because this one broke on this one, I know it's a common failure because people were saying it online. I think I'm going to put this known working one in here, and I reckon then it's going to start working. So I'm going to put this one back in for the moment and put the opto coupler back in, and I'm just going to swap out this one. If that doesn't fix it, we'll go from there. It's quite nice actually, because they've got a little line here on the opto coupler, so you actually know which way to put it round, because you can see that there's a line going down here on it. I just want to put this one in here, see if it reads any differently. Right, so 609 and 555. Not far off, is it? Well, you know, that's all I've got to go on at the moment, is just what happened before. So let's pop this one in here. Let's see if it starts working. Tell you what I'm going to do, I'm going to pop this one in here, and then it will allow me to keep testing, you know, with all the circuits in. Right, so this is the faulty power supply here, but with the known good component here. Everything else is the same as it was originally. I put the suspected faulty component into this one here because I don't think it's going to make a difference. I don't think that's faulty because it's measuring the you know, similar readings on here. So anyway, let's try the faulty one to begin with, just in case it does come to life. Right, here goes. I'm going to keep my face out of the way for a moment. When I plug it in now. Okay. Let's see if we have any outputs. No way. We've got it. 8.8. So it's that faulty component. 5. Wow, so even though it's testing okay, it's obviously not. Why is that not giving me anything? This should be 3.3 volts. Oh, hold on. Uh-oh. One second. Yeah, 3.3, fantastic. Wow, so just a common, that must be just such a common failure. Right, okay, let's unplug that. And I am going to plug it into this. This is so loose, look at that. I wonder how you tighten that up. Mind you, that isn't much tighter. Right, okay, now this one shouldn't work. This was the working one before. Plugging it in now, and let's see. No. Okay, well at least we proved it. Right, okay, so let me unplug that. So yeah, just goes to show that even though it was coming up as 2 diodes in here, obviously the chip is more complicated than that. It's not a double diode package, is it? You know, it's not the same as that one there. It's doing a lot more. This is a very clever chip here. So yeah, you can't always use a component tester like that, because prime example here, they look very similar on the readings coming up with both 2 diodes, and you think, oh, it must be okay, but obviously it's not. So I'm going to leave the good chip where it is now, and also I'm going to take the on and off switch. I did actually have a look at the on and off switch. I tried to glue the bit back in, but it just failed on me. Using super glue on something like this, it just makes a complete mess. And that on and off switch needs to work perfectly. I did actually film it. There's no point in showing you it because the outcome was not successful. Then I got my soldering iron involved, and then it just ended up making a complete and utter mess. So I'm ordering up the chips from China because they're pretty cheap. and I'm also ordering up the on and off switch from China as well. So I'll just show you the listing of that. I'm going to take the on and off switch from the previous working Sega Saturn to get this Mark 1 all up and running, and now I'm just going to show you some footage of the Mark 2 being put back together a few weeks later once the on and off switch has arrived and also once the new chips have arrived from China. Let's plug it in and see if it lights up. Fantastic. Brilliant. Right, let's pop a game in and see if it spins. Should be able to see it there, but there you go, you can see it now. See here? And I can hear it as well. Excellent, so the Mark II Sega Saturn that I fixed up previously is now working again. And now let's go back a few weeks when I connect up the Mark I Sega Saturn, the original 41, onto the TV and we can test it. Right, here it is, all looking nice and pretty. And check this out. Turn it on there, comes alive, and there we have it. Now I've set the time, so let's see if the time stays, or will it make me input it? Right, okay, good. Right, let's see if the... I haven't actually tried a disc yet. Let's see if Sega Rally is going to work. It looks so arcadey.
3, 2, 1, go!
Oops. Oi! I'd like to get him back, but I'm not going to be quick enough, so yeah. So that's it. It looks like it was just that three-legged IC again, just like the last Sega Saturn. I say worldwide, there must be hundreds, if not thousands, of these that have failed because of that. I'm not sure if I'm going to get any more Sega Saturns now, because I think that's going to be such a common problem on them. I think the sort of enjoyment's going to be gone. I'd quite like it if there was a Sega Saturn with a faulty board rather than just a power supply. That would be more interesting to fault find. But still, the Sega Saturn wasn't working and it's working now. So very, very good. Just can't get over how good that is on RF. So if you enjoyed the video, give it a massive thumbs up and I will see you all very soon. Take care of yourselves.